In this example, they want you to simplify and express your final answer with a positive exponent, and again without using your calculator. We're going to follow the same rules we followed before when it came to multiplication and division, which is powers with the same base allow you to just add the exponents. Many of you won't have to write this work out, you can do this in your head, but the base is going to be 4 and the exponents are 5 plus negative 3. So plus a negative means subtract, so 5 plus negative 3 becomes 2. And that answer is a positive exponent, so I'm done there. They do also want us to evaluate it without using our calculator. So 4 squared is 4 times 4, and I know that's 16. In the next case, let's do the same thing. I've got two powers with the same base, so it's going to be 3 to the 2 plus negative 5. In this case, that gives me a negative number. 2 plus negative 5 is negative 3. Now, here's why you have to know how to solve a negative exponent, because 3 to the negative 3 is not something I can do in my head. So, what we learned today is that a negative exponent really means you can just change the location of the power. So 3 to the negative 3 becomes 1 over 3 cubed. Notice how the exponent becomes positive. Now that's a number I can solve in my head. 3 cubed is 27, so it's 1 over 27. In the next part, they do have a number in the denominator that has a negative exponent, so I also have to change its location if I'm going to make that positive. So what used to be a fraction, 1 over 2 to the negative 5th, really just has a value of 2 to the 5th. So whenever you see a negative exponent, you can change its location to make it positive. In this case, I changed it from being in the denominator to being in the numerator. And what happened to the 1 is just 1 times any number is going to be itself, so it's not necessary to write 1 times 2 to the 5th, though you could if you wanted to. And if I evaluate that, 2 to the 5th, I know is 32. For part D, students are often tempted to switch each number to make the exponent positive. I would suggest you simplify first and then see if moving is necessary. So in this case, I have two powers with the same base, so 6 to the negative 7, and I'm dividing, so that means I'm going to subtract my exponents. Just be really careful with this. That's negative 7 minus negative 5, or, again, I'll just show all my work here. That would be like saying negative 7 plus 5. So I get a final answer of 6 to the negative 2. Now, I know to make that positive, I'll have to put it in the denominator. Right now, it's a whole number, 6 to the negative 2. So I'm going to write it as 1 over 6 squared, so that I could easily solve it in my head as 1 over 36. Now you could have moved the 5 first and then the 7, but I think it's just making a lot of extra unnecessary work. Okay, finally the last one, 2 cubed to the negative 1. Well, let's use our power of a power law there that says 2 to the 3 times negative 1, which is really 2 to the negative 3. Now it's a whole number. There's no fraction yet, so I'm going to have to move that to the denominator in order for it to be a positive number. So there's my answer with a positive exponent, and evaluated that becomes 1 over 8.